This is the skill video for Unit 1, Skill 7 on compound inequalities. And a basic definition is written at the top here. A pair of inequalities joined by and or. And we'll look at some examples of what that means, but we're looking at two inequalities joined together again by these two words, either an and or an or, and that's what makes them a compound inequality. Let's look at a basic example of each here. For and, I could write x is greater than -1 and x is less than or equal to 3. Okay, so we have these restrictions for x. It has to be greater than -1, and it has to be less than or equal to 3. Okay, we can actually write this a little more compactly when it's an and. Okay, I can take the inequality that has the smaller value, right? This -1 is smaller than the 3. And this one goes on the left, and I'm going to actually flip this around and write -1 is less than x, right? So those two mean the same thing. And then I'm going to bring down the x is less than or equal to 3, but I'm not going to write the x again. This x already replaces that x, and so I just bring down the less than or equal to 3. So here you have x kind of trapped in between the two inequality symbols with our two number values on the far left and far right. And so we would read it as -1 is less than x and x is less than or equal to 3. Right? So I still used that connector word and when I said that phrase. Let's take a look at what values this represents on a number line. Okay? If I kind of drop down those endpoints, -1 on one boundary and a +3 on the upper boundary. Okay, and we're looking at all values where x is greater than -1. So that means an open circle at -1, and we would be shading to the right for greater than. Okay, and then the second inequality is that x is less than or equal to 3. Now that means a closed circle on 3 and less than, which would mean shading to the left. Now notice these two intervals are overlapping, right? Kind of the purple and the red, they're overlapping. And if x has to be greater than -1, okay, so to the right of -1, and it has to be less than or equal to 3, we can't have x values outside of these two boundary points. And so what we end up having is just this shaded region in the middle, right? The overlap of those two intervals just between -1 and 3. Now we still have the open circle at -1, and we still have a closed circle at 3. This is a very typical graph for these, the compound inequalities with and. Okay, so what we're doing is we shade the overlap. And so it's just this small shaded region in between those two boundary numbers, -1 and 3. Now let's look at an example of an or. Let's say that x is less than -1 or x is greater than or equal to 3. Now that word or in the middle is an important difference because we're saying that x can be in one interval or in the other. We're not looking for values that have to be in both intervals. So we're not looking for the overlap of these two intervals, just both intervals together. So we don't need to rewrite this in any special way, and we can go straight to a number line. Okay? So let's go ahead and get our values on here for the boundary points. We've got a -1 and then a +3. So for the first part here, if x is less than -1, that's an open circle at -1, and we would shade to the left for less than. And then for x is greater than or equal to 3, we would have a closed circle at 3, and we would shade to the right for greater than, right? Those are where values are greater than 3. So notice here that these two intervals are going away from each other. There is no overlap, but that's okay. Both of these two intervals together create the shaded region for all x values less than -1 or greater than or equal to 3. So that's what the graph would look like.